Welcome to this class, Olusegun Maths Clinic. We are hereby to solve for the value of x. But this type of equation is what you call differential equation, whereby we are going to apply the method called integrating factor. So how do you start doing this? Number one thing is, let's divide all through by the value of x. Let's divide all through by x. So we have x dx divided by x plus 2y divided by x is equal to 3x divided by x plus 2 divided by x. So you know that x will cancel this. So now you just try to have this value. We have dy dx plus, so let's try to make y here to have 2 over x because we have a value to use there. We have x, we cancel x, we have 3 plus 2 divided by x. Now there is something that we call integrating factor in differential equation. The coefficient of y here, it is what we call integrating factor. So that is what exactly you need to know, and that is what I want to teach today. The integrating factor. Integrating factor is the exponential. It give you the exponential raised to power 2 divided by x dx. So you differentiate the value of, so we have, if e raised to power integral 2x dx, meaning that you can write to have 2 integral 1 over x dx. And when you integrate the reciprocals of x, we surely have exponential 2 ln x. That is just the meaning. So in writing the 2 ln x, you write it in logarithm form. Well, we have exponential 2 log x base e. So from the law of logarithm, it can also be written as exponential log x squared base e. And since it is exponential that also raised to power the base of an exponential, so therefore all this value will become s squared. So that is just the value of the integrating factor. So in differential equation, after you have gotten the value of integrating factor, so the next thing you do is you multiply the value of s squared to the first equation. He said, let's multiply s squared to our equation. Let's say equation 1. That's our first equation, which we have. And the equation is this. From the questions, you're able to see from here, which is dy dx plus y. So we are multiplying the value of x with that equation. So we have s squared dy dx plus s squared dot y dot, we have 2 over x the other time, is equal to 3s squared, because you multiply 3 with s squared, plus s squared dot 2 over x. So which we have s squared dy dx. The x will cancel this, it will remain 1x. So plus xy dot 2 is equal to 3s squared plus, so by the time we multiply this will cancel this, we have 2x. So in having the value of this, in having the values, so we have, this is let's try to do it well. So here, good. We have x squared dy dx plus 2xy is equal to 3x squared plus 2x. So therefore, in having this, you have to discover one fact, that x squared dy dx plus 2xy, let's try to remind us about what we call differentiation by the product rule in differentiation. For example, you have to differentiate x squared dy in differentiation. You know, this is a product rule. Let's leave x squared and differentiate y in implicit form. We have this now, plus we leave x squared, we differentiate x squared. When you differentiate x squared, we have 2xy. So if you're able to see this now, let's try to let you understand one fact, that this derivative of this is also this. So it's also this equation. So instead of writing x squared dy dx plus 2xy, just write, for you to get it better, just write d x squared y dx will now give us 3x squared plus 2x. So since you're able to get that now, we are able to try to reduce it to a minimum form. So in reducing it to a minimum form, for you now to having this, let's try to do another formulas, which is said, let's try to integrate the both side. So if for integrating the both side, we have d onto x squared y dx is equal to integral 3x squared plus 2x dx. So for integrating the both sides, this integration will cancel this. That is all the meaning. So it will now give you, s squared y is equal to integral 3x squared dx plus integral 2x dx. So you now start another integration forms, which you have. So another integration form will now give you. So we have s squared y plus, try to bring the 3 out, integral s squared dx plus 2 integral x dx. So in integrating this, so having integrating this, so we have s squared y is equal to 3s cubed over 3 plus 2s squared over 2 plus c. So therefore, since you're able to have gotten this, let's try to divide all through and see what is happening. So the 3 we cancel 3, 2 we cancel 2. So here therefore we have s squared y is equal to s cubed plus s squared, that is s cubed plus s squared plus c. But our question is to find the value of y. How do we find the value of y? So let's try to divide all through by s squared. So that is the next step. Let's divide all through. Let's divide all through by s squared. So in dividing all through by s squared, we have, so in dividing all through by s squared, we have s squared y divided by s squared is equal to s cubed divided by s squared plus s squared divided by s squared plus c divided by s squared. So because we need the value of y, In finding the value of y at this junction, so this we cancel this, we have y is equal to, this we cancel this to remain x plus sk, we cancel sk to be y plus c x raised to power minus 2. So this is just the value of y that we will be looking for. So this is what we call differential equation. So we use differential equation to find the value of y at this kind of question. So don't forget to subscribe to this channel and try to share this video, especially who you believe might need this wonderful explained solution. Thanks.